Okay, so welcome back, and now we're going to do an example where we have something like this. And so again, you're going to want to make sure that you know your trig integrals, u substitution, partial, or not, obviously partial decomposition, but integration by parts and so on, okay? And sometimes you got to think outside the box and think about how I can manipulate things to make it work. So this example will show you what I mean. So now, in this example here, we have dx over x cubed minus 8. Okay, so now the first thing we need to do is first that obviously the bottom is the degree of the top is less than the degree of the bottom. And so now we need to factor this. So the thing is you have to recognize that this is in the form of x cubed minus a cubed. It's a difference of 2 cubes, okay? Because this can be written as 2 cubed, okay? And we know, if you, again, remember the special forms, this is always going to be a minus, x minus a times x squared plus ax plus a squared. Okay, so now we're going to rewrite this as the integral of dx over x minus 2 x squared plus 2x plus 4. Okay. Now in this case, there is no way to factor that quadratic. Okay, it is an irreducible quadratic expression. Okay, so this is as far as we can go with this. Okay, so now we need to set up our decomposition. So again, this is going to equal, so we got a linear term, so this is going to be a over x minus 2 plus, now this is a quadratic, irreducible, so the next term is going to be bx plus c over x squared plus 2x plus 4 dx. Okay, so now we need to set up our scratch work to solve for this. Okay, so let's do that straight away. Okay, so now we've got 1. So again, there's a 1 here. So I'm going to use the equating the numerators. So I'm going to set up my equation. So it's going to be 1 equals cross multiply, right? I'm going to set up my equation. So it's going to be this times a and this times this. So my equation I'm going to solve is going to be 1 equals a times x squared plus 2x plus 4 plus bx plus c times x minus 2. And now I'm going to simplify this or rearrange things. So this is going to be ax squared plus 2ax plus 4a plus bx squared minus 2bx plus cx minus 2c. Okay? And now this is equal to 1. And so now I get 1 equals, now I'm going to get, well, I've got a plus b times x squared plus 2a minus 2b plus c times x. And then I've got the quantity 4a minus 2c. Okay, now I just put them in parentheses just to group them. So I see that, okay, Since I've got a 1 here, I don't have any x terms. I don't have any terms with x's in them. So that tells me that this is going to be 0. This has to be 0, and of course, this is equal to 1. So now if I set up my system of equations, then I get a plus b equals 0, 2a minus 2b plus c equals 0, and then I get 4a minus 2c equals 1. Well, now I can ignore this. I don't need this anymore because this is what I was getting to. So now this tells me that a equals negative b. Well, then if I use that information with the second equation, I get what? I get 2a plus 2a plus c equals 0, which means 4a plus c equals 0, which means c equals negative 4a. Okay, good. Because now I can use this in the third equation to solve for a. Because in the third equation, I get 4a minus 2c, but c is equal to negative 4a. Equals 1. And so now I get what? 4a plus 8a, which gives me 12a equals 1, and so a equals 1/12. So now I'm going to put 1/12 here. Okay, now, everything basically starts to solve itself, because now, since I know a is 1/12, that means b is the opposite of a. So it's negative 1/12. So this is negative 1/12. And c is negative 4 times a. So if a is 1/12, then c is negative 4 times 1/12, which is going to be negative 1/3. So c is equal to negative 1/3. All right. So now we can erase all of this. And now we're gone to the next stage, which is evaluating this thing. So now I'm going to pull out on a 1/12 here. So, and I'm going to split this up into two integrals. Okay? So this is going to be 1/12, and we get 1 over x minus 2 dx. And I'm going to factor out a negative 1/12 here, because I want integers here. So if I factor out a negative 1/12, that's going to leave a 1 here, and that's going to leave a 4 here. So if I minus 1/12, the integral of, and I get x plus 4 over x squared plus 2x plus 4 dx. Okay, now this we can do easily. I'm not going to do that right now, but this is easy to do. This one, not so easy. Okay, because I don't know what to do with this. There's not an easy way to do a u substitution here. It's not factorable. Okay. Here's something to keep in the back of your mind when you're working on these. If you come across something like this, we want to put it in a form where we can do a u substitution. One of the best ways, one of the techniques that we can use is completing the square. Okay. So what we're going to do is we're going to change the way this looks by completing the square. So I'm going to group these together, and I'm going to complete the square on these two terms. So that's going to give me x squared plus 2x plus 1 minus 1 plus 4. Okay? So all I did was add 1 and minus 1. So I'm adding a form of 0 here. So I'm not changing the polynomial. I'm just changing the form of it. Okay? So now this becomes x plus 1 squared. It's a perfect square. And then this over here becomes 3. So I'm going to replace this with this. Okay, so let's do that. So I'm going to get 1/12, 1 over x minus 2 dx minus 1/12. And now I'm going to write this as x plus 4 over the quantity x plus 1 squared plus 3 dx. Okay, now we're going to do a u substitution. Let u equal x plus 1 and du equals dx. Okay, now, a couple ways you could do this. Okay? You could solve for x, right? We've got x here. You could solve for x and let x equal u minus 1, right? And so then what do you get? You get, again, 1/12 the integral of 1 over x minus 2 dx minus 1/12. And so now what do? The x minus 4, right? The x becomes u minus 1, so then you get u minus 1 wait a minute, oh, this is a plus. Plus 4 over u squared plus 3 du and so all this here on the top just becomes u plus 3. Okay, now you could have just, that's again, that works every time. But if you notice that if u is x plus 1, you could have just shaved off a 1 here and wrote this as x plus 1 plus 3 and then did your substitution that way too. That works just fine. Okay. Okay, so now we're going to split this into two fractions. Okay, because right now, if we do a u substitution, we've got our u substitution, but we still got a problem here. So I'm going to split this up into two more fractions. So here's what I'm going to do. I'm going to write this as 1/12 the integral of 1 over x minus 2 dx minus 1/12 the integral of u over u squared plus 3 du plus 3. Oops, let me do this. So we could do it that way. Okay? Again, you don't have to split it up into two different integrals. That's what I did. Okay? And it's nothing wrong with doing that. You could split it up into two and do it term by term, but again, I'm just making it more obvious. Okay? So now what? Now we're ready to evaluate this thing. Okay? So this one's good, and then this one here, we're going to have to look at it a little further. Okay? Because that's going to be that's going to be a form of tangent inverse. Because I can look at this as u squared plus a squared, where a is equal to the square root of 3. So that's what we're going to do. Okay, so now watch what happens. So now, this is going to be 1/12. This is going to become the natural log of the absolute value of x minus 2 minus 1/12. Oh, this is u substitution, so this is going to be the natural log of u squared plus 3, the absolute value of. And now this one here is going to become 3, so I'm going to pull it, it's going to be 3/12, which is 1/4, right? Because again, don't forget this 12th here. Oh, so this is going to be minus. So I've got the minus 1/12 here, so that goes with this one and this one. So I've got 3, and then I've got the du over this. Okay, so but in this case here, this 3, a is going to be square root of 3. So what am I going to do with that square root of 3? Oh, hold on a second. Keep forgetting. This is easy to do. Where is it at? Oh! Yeah, right here. Okay, so even though you've got u squared, there should be a 1/2 here. And the reason why there should be a 1/2 is because if you do another substitution, remember it's du over u. Okay, so the only reason we did the u substitution here was to make this simpler so we could split this up. Okay, so now this we're going to have 1/2 here, because if we take the derivative of this part here, we're going to get a 2 when we take the derivative of the bottom. Okay, so if you want to see that more, we can split it up and do another do a v substitution, if you will. So if we do a v substitution, let's do that. So let v equal u squared plus 3, and we'll let dv equal 2u du. So 1/2 dv equals u du. And if we write this way, we get 1/12, 1x minus 2 dx minus, now I'm going to distribute the 12, so this is going to be 1/12, but there's going to be a half here. So that's going to be 1/24, and that's going to be dv over v plus, oops, not plus, minus, I'm going to pull the 3 out, 3/12, the integral of 1 over u squared plus 3 du. Okay, so now you can see it more. So if you do you have to be careful, because if you don't do the substitution again, then you might miss, like I did, the 1/2. Okay, so let's go up here. And continue. Okay, so where are we at now? Okay, so now we're almost done. So we know how to integrate this, we know how to do this one. This one, you just have to remember, this is inverse tangent, right? The integral of this is going to be an inverse tangent, but this, remember, again, this is a squared, which means a is equal to the square root of 3 in this case, okay? So that means you're going to get a square root of 3 in the denominator. Remember, it's going to be 1 over a. So in this case, it's going to be 1 over the square root of 3. So this is going to be a fourth, right? So we're going to put the 3 in here, and let's rewrite this. So this is going to be (1/12) minus 2 dx minus 1/24 dv over v minus, this is going to be 3/12 over, oh, I don't want to do that yet. I don't want to do that yet. Okay, so now, okay, so now let's integrate this thing. This is going to be 1/12, natural log of the absolute value of x minus 2 minus 1/24. Now, this is going to be the natural log of the absolute value of v minus 3/12. Now, again, this is going to be 12. Now I'm going to pull out the square root of 3 here. And this is going to be tangent inverse of u over the square root of 3 plus c. Okay, so that's what we're going to get. So we're not done yet. Let's simplify this. So we still got v, we've got to put everything in terms of x now. So we've got a back substitute for u, we've got a back substitute for v, and we need to take care of this too. And we can't have square root of 3 in the denominator. So we got to rationalize this, okay? So this is fine, we're done with that. So this is going to be 1/12 natural log of x minus 2 minus 1 over 24. This becomes the natural log. Well, what was v? Or excuse me, what was u? Okay, u was x plus 1. Okay? But in this case, what was v? v was u squared plus 3. Now this here, I'm going to multiply the top and the bottom by the square root of 3, which will make this 3, and that will cancel with the top 3. So what I'm going to end up doing is I'm going to end up getting 3 times the square root of 3 over 12, and then 3 square root of 3 squared, right, is just 3. So this cancels with this, and I end up with the square root of 3 over 12. So I'm just going to write that. Okay. So now I've got things in terms of u. This is fine. So now all I have to do is just put things back in terms of x. So now this is 1/12 natural log of x minus 2 minus 1/24. The natural log. Now u is equal to x plus 1. So let's put that in there. So this is our x plus 1 squared. So this is going to be x plus 1 squared plus 3 minus the square root of 3 over 12 times the tangent inverse of u is x plus 1 over the square root of 3 plus c. And now we're almost done, except now this here, we don't leave it this way, because really what this is what we had when we completed the square. Well, we want to undo that. So what did we have before? Well, this is going to be the final answer. We get 1/12, the natural log of x minus 2 minus 1/24 times the natural log of the absolute value of, now this turns out to be x squared plus 2x plus 4, right? Minus the square root of 3 over 12 tangent inverse of x plus 1 over the square root of 3 plus c. And that is the final answer. Okay? See you next time.